Greetings. Welcome to Dynamics for problem 1570, and we are still in general plane motion. Here our rotating and translating object is a tire. An automobile travels to the right at a constant speed of 48 miles per hour. If the diameter of the wheel is 22 inches, find the velocity of points B, C, D, and E on the rim of the wheel. And I've drawn those 4 points on our diagram here. The center is A. Also, a couple of angles were given, 90 degrees and 30 degrees. Find VB, VC, VD, and VE. And I'll go first and find VC, because as we know, any two things in contact without slipping, moving without slipping, will have the same velocity. And since VC is in contact with the ground, and the ground isn't moving, the ground has a velocity of 0, then VC will also have to be 0. Now we can use the general plane motion equation for A and C. So what do we know about C? It has a velocity of 0. What do we know about A? It has a velocity of 48 miles per hour. Oh, by the way, that's 70.4 feet per second. So these are 2 points on an object. The velocity of one, A, equals the velocity of the other, C, plus the velocity of A with respect to C, which, as we know, is the distance times omega. So we will find that we know VA, 70.4. We know VC, 0. We know the distance, 22 inches. The only thing we don't know is omega. So we come over here, 70.4 equals 0 plus 11 twelfths, 11 inches. Ooh, I said 22 inches. The diameter is 22 inches. The radius is 11 inches. And we'll convert to feet, 11 over 12 times omega. Only unknown is the angular velocity of the wheel. Solve for it, and we get 76.8 radians per second. And if the wheel is moving this way, the tire is rotating that way. And if the tire is rotating that way, we get a clockwise angular velocity. So, what do we have? We have VC and we have omega. Guess what? Once you have omega for the wheel, you've got it for the wheel. It's true for every point on the wheel. For any object, once you have its omega, you have its omega. So now we can find all these other points, B, D, and E. So let's walk along. I decided to find VB with respect to point C. So that's like moving up here. Here's B. I'm going to go from C to B. So VB, VC, the distance from B to C times omega. We know all this. VC is 0. The distance from C all the way up to B, 22 inches. Convert it. Omega, we got it. 76.8 radians per second. Do the math. And we get 140.8. And we know that that velocity is perpendicular to the line from C to B. Perpendicular from that line is straight right. So 140.8 feet per second to the right. Let's go to D. I think for D, which is over here, rather than going from C, which I could, I think it's easier to go from A, because I know the angles and I know the distances. So for D, I'm going to start at A. VD equals VA plus RD with respect to A times omega. Well, VA is moving. Let's use an I and a J, I for the X and J for the Y. VD is moving at 70.4 to the right, or 70.4 I. The distance from D to A is 11 inches, so 11 twelfths. And omega is 76.8. But, let me change colors here. It will be, VD will be perpendicular to the line from A to D. So we have to take this VD that we've got and get its angle and break it up into its horizontal and vertical components. And if this angle is 30, that angle is 60, that angle is 30. So we take the RDA, 11 twelfths, times 76.8, and we get 70.4 again. Take 70.4 times the cosine of 30, that's the I. 70.4 times the sine of 30, that's the J. Now we can combine our I's and do a Pythagorean of this combined with that to get 136 feet per second. And do an inverse tangent, and we'll find out that that angle is 15 degrees. So there's VD. Now VE.
Yep, see you later. Whoa! Did I bring my phone?
Had an interruption there. Sorry about that. VE. Let's see. Where is E? It's out here. Where should we go from? We could go from C. That wouldn't be that hard. But I think I'll choose to go from A, because that's just straight across. That looks pretty fun. Yeah, I'm going to go from A. So VE equals VA, again, 70.4 I, plus the distance from A to E, that's the same old 11 twelfths feet, times omega, that's the same old 76.4 radians per second. And that VE with respect to A is going to be perpendicular to AE, or straight down. So we have 70.4 I to the right and 70.4 J down. Pythagorize that, and we get 99.6. Take the inverse tangent. That's one we can do in our head. If we have the same two numbers, it's going to be 45 degrees. There's VE. So this is what we did in our class video as well. And we now have in the books here 3 different problems from chapter 15, and they're really following a pattern. We have places where we know the velocity is 0. We have places where we know that 2 points in contact give us the same velocity. And we use this equation time and time and time again for general plane motion. We'll revisit this with some more problems in the future.